aquaculture facilities, where are the fish, with the three objectives: characterizing the different aquaculture breeding structures, and another objective is know how to analyze the criteria for choosing, how to dimension. You will see it tomorrow morning, according to the production objective. You have here the ratio we speak just. And third objective, reasoning the organization of space when designing structures. Some of you have project for building, and you have to ask you some question. I think you became you start asking you question, I'm sure. Weaving enclosure, we will see it for the materials, the shape and the cost. Choice of materials, some things to know to make the right choice. Organize space, and finally, one little point, how the water can be transferred by different hydraulic mode. Materials, more common materials is plastic. I take here all the denomination. I don't read ever, but polyethylene, high, low density, PVC, polyvinyl, and every one have a number, and the symbol of it could be recycling. Different characteristics of plastics. I say recyclability. Almost can be recyclable, but in practice, and it will depend for the country and for the place you are in a country, we do it frequently for polyethylene, high density, number 1 and 2. Stability of the plastics are important too. Polyethylene high and low density are pretty good for that, and polypropylene too. Be careful to PVC. We put in it plasticizers which contain, I suppose you heard about this term of phthalate. Question, or for another chemical product which is in the plastic we don't speak about from yet. It's polycarbonate. It can cover the structures, which contains bisphenol A, an estrogenic chemical, which have an impact of hormonal and fetus development. There is no study for the fish, but we can think that if there is impact of the human, there will be an impact for the fish. The use of phthalate and bisphenol. Bisphenol is to to give the plastic the same properties when we is going in higher temperature. Plastifian are how to make them to protect them for the aggression of the from the light, from the UV environment. We continue with other material, glass. Good for health, for stability, but the light is going through this material, and the consequence is boost of proliferation of algae. You speak about fouling. I think it's the word you use, fouling, development of algae. So that's not so good for the fish production. In aquaponic system, you have very big farm, industrial level, but you have also a small system, individual system, self-made system, and so you have to think about a solution you make with the material you find near the place you live, and which is corresponding to exactly to what you want to do. Wood can be used, masonry with conquest, or a hole in the ground, very basically structure, galvanized metallic structure, structure we found. And all these structures are covered with a liner, which name is EPDM, a black liner. You see what it is? Yes? Or another liner, which is a PE for roofing, or for the truck. You see it for protecting the truck. Good for the flexibility. You do more or less, you cover the structure you want, and the cost is not, we will speak about cost after, but it's a low cost. Another material is fiberglass reinforced plastic. Well common material. You see it here from the circular, when you visit the pisciculture, circular in the enclosure nursery, you have it. Very resistant to shock, to light aggression. And for the fish, if there is no deterioration, the surface with resin is good for the fish. But the cost is higher. In reuse, we also can use stainless steel, such as drinker for the cow or the animals, which resist in the time. bathtubs eagerly. We will speak about the shape, but the shape of our bathtubs is not so bad, and the material is good. You don't have the choice of the shape. But on the philosophy of the aquaponic cycle recycling materials, it have a sense. Another part of the shape questions, a lot of general rules. Depending from the species, you have to adapt the shape for the fish living. And we can give this value of deep 0.5, 1.5 meters deep. It will be works. After that, you have fish we like to be close one to the other at the bottom, other to swim more. And efficient for two questions. First of all, water circulation. You want to have a good water how would you say renouvellement? Yeah. To put out the water and fresh water in all the part of the tanks. Thank you. And second efficient you have, it's to disposal of solid waste. You don't have to have a place in the tanks where the sludge, the solid waste are being staying. Okay. Wasteway, we use this terminology in French, wasteway, such like in the pisciculture. You see it, it's often in concrete. Enlarged rectangular shape. Good for the circulation of water because you have velocity, movement directions with its clear. But the output of the water, it's at the high level, such as the solid waste don't be it's not facile, it's not easy to to collect solid waste from the bottom. The tanks family in GRP, you use this term for, yes? Square or circular, and you see it's a mix from square and circular. Capacity 100 liter to 20 cubic meters. The circular are this system. solid waste can be collected on the middle part, on the bottom, and going here. At small unit can use ABC bins for ABC for intermediate bulk container, which have the, it's good for the plastic it use. High density polyethylene is not a bad plastic for stability. Reinforced with a grid and easy transportable because you have, see, I don't know the word, pallet in French. Yes, yes, pallet? Okay. Can use a NG like a Fenwick to put it in other place. Capacity 1 cubic meters. Smaller system can use food barrels, the same plastic, not so bad, high density polyethylene, and you can cut it on the dimension you want, horizontally or vertically. You can go to 200 liters. If you are, for the philosophy, adapt from the recycling, it's good, but be careful of the first life of the barrels. If it have contained chemical, you can think that just washing it can be good, but it's not the case for many of chemical products. We contaminate the plastic, and you can not be, you don't have you don't be sure that there is no chemical after the washing. Shape of structure, what can we say? And you can use the grid, the analysis grid, to put some information inside. We will say that it's circular or square, even as mix of the both we see here, yeah, is the better shape. Flat bottoms, for the fish which like to spend time on the bottom, like sturgeon. And think about facilitate of the layout. We will speak about layout after the organization in the space. One point of the cost, you can if I always give some value of the cost of the structure, enclosure can represent 20% of the total cost of the unit. And I put some cost from liner. you buy it in quadrat meters, but after that you will cover the structures, and it can make for you 20 euros per cubic meters. We don't speak about the structure cost here. After that, from barrel, IBC, and GRP tanks, the costs are very different. The low cost is the IBC.
I think it can be lower if it's recycled. I guess the first one, we were buying them for like 10 euro.
Yes, that's you buy it new at this cost. Yes, yes, it can go to 0 if you find it. Yes, and I just for comparison calculate it for 1 cubic meter. So it's came of this high cost, but if you recycle it, it can cost you 0. And yes, this can be useful for you for 1 cubic meters. GRP are well used. Here you can give signification to this 20% because it can be going very fast when you buy new GRP tanks. These costs are in French. We have the COFA. We have some cost we find easily. Selection of materials. You can have question about sensitivity to physical aggression, exposed to the UV environment or shocks. We speak about chemical aggression, water aggressiveness, you don't have the choice of the water quality. You have to use it, and be careful if she is poor in element. She ever want to take the element in her environment and can use this element in the material and contaminate the water. Non-abrasive, the lifetime. Color white, and ABC is not bad for that. White container allow to reflect sunlight and keep water fresh. So it can be white, but don't allow the light to go through because of the fouling we speak about. Easy handling and cost. After that, when we speak about the space organization, at the first step of one project, you have to work with a plan and positioning the structure in the space you have. Here it's a good example. Lozère, there is a lot of space, you see that. But in here, after you have the administration, different other structures, the salmoniculture, there is not so many places, and they have to, when the project starts, they put them a lot of questions to if we have the much space to do the project, and how to access to water, and a lot of things we need. Energy. What about the land? You have to be stable and leveled. If it don't be stable, you can casting concrete blocks for the fit of the structure. Why laying the structure on the ground? For two reasons. Facilitate the installation of hydraulic equipment. The bottom of the system are accessible. You have access on the bottom of the structures. And for the work of man, height, you work at the same level on the structure. French people suffer from backache, and the boss say we have to carry heavy load, and the workers say we are being asked too much flexibility, and both have a backache. Continue with the planning of space organization. Avoid many things: exposure to wind, rain, and snow, depend of the climate and the country. Avoid weed growth. Laying the bottom with laying the grow with tarpaulin. Tarpaulin is seems like a liner, and the grow couldn't came. Be careful to the direct sunlight. The fish doesn't like it. So you can put the structures in a naturally shaded space, or put a shape equipment over all the structures, or over each tanks. Over each tanks can have another interest, the shape, but how that the fish don't jump. Okay. Other question you have to answer: thinking of water supply and drainage, evacuation. If you use air and or oxygen, how to have access to the pipe of oxygen. Power supply, well mark comment on dit le trajet, the road of all the system you will put in the earth because of security. And how you will access for the fooding, for example, with bucket or wheelbarrow. Large access. When we will do this work, you will walk inside the structures, and you have to ask you if it's possible here to work with 2 buckets of pellets, and came inside with a wheelbarrow. You see, we want to be able to walk easily, but there is a lot of things: drainage, water supply, air, power. There is a lot of pipe, and it have to be accessibility too. In conclusion, for the space organization, we can say that it's important for two things: working ergonomics, in order that the work is a facility and you have a pleasure to work in these structures. And another thing, it's the modular and evolving structures. Today, you plan to build an aquaponics system, but tomorrow you don't know if it will be aquaponic for a long time, and even if you have other idea of experimentation. So do the best system for aquaponic, but it's important to think about how the structure can evolving for another experimentation in the future. The last point we will speak about tomorrow, it's hydraulic transfer modes. We will speak about three. The low cost is continuous gravity, good for draining the tanks and all the solid waste you have. Pay attention to the minimum gradient. We speak about 1%, 1 meters different of level for 100 meters. Avoid low points. If you have low points, you have gradients with change of sense. It's not good. You have a stock water who don't on sludge. You can accumulate sludge in this point of the system. Gravitated system by bell siphon. It's not really. It's much more for the speak of Catherine, but I put it here. It is water putting on the system in continue, and so the level is going to the top. Here, the siphon is becoming to be full of water, and it starts the siphon system, and at the end, when the level is here on the bottom, there is air which is coming inside and stop the siphoning system, and we came to the first step. That's a system which is hydraulic, no energy, and there is just a little thing you can see here. A simply little bucket, which is here. It's important for the system because not here it works without, but at the end of the siphoning, it's give time because of the different of level here to stop the siphoning system. Here. Okay. Here, without this bucket, you can have the level of water here, which is going up, and don't allow the water, the air to come inside. You are with me? No? Yes. And with the bucket, even the level of water inside the structure is going up. There is a time which is longer to the air in. Okay? That small adaptation, and it works. Such I say, without energy. The last hydraulic transfer is by pumping. You always require a pumping system from the WAS. So you can have the question, where is the pumping system on the system, which place you give for the pumping system, but you can make without. You can do without. Thank you.